And to talk you through the night next on 5 Live, the inimitable Mr. RhodSharp.
Thank you, Phil. Later on Up All Night, Jimi Hendrix's record collection and other curiosities of his London flat now open to the public. The jet stream's getting faster and it's taking longer to get to New York. And while it's on to South Carolina for most presidential hopefuls to say goodbye. Well, flights from the UK, from London or some of our other airports to the United States, especially the East Coast, are taking longer because of climate change. Researchers say it's likely that the powerful winds of the jet stream are speeding up. Dr. Paul Williams is an atmospheric scientist at the University of Reading who carried out the study, and he told me what he'd found out.
Well, the new study that we've published today calculates that the jet stream winds are getting faster by 15%, and that's along the flight route between London and New York, which is, of course, the iconic transatlantic flight route. So those jet stream winds getting 15% faster, and that's going to have consequences for people's flights going forward.
Yeah, you would think so. But any flight I've been on that route recently, we seem to have made it to London in record time. The planes are getting faster, if anything, because of the assist that you get from the winds going east to, west to east?
That's exactly right. Yep. The jet stream blows from west to east. It can reach speeds of 200 miles an hour on a good day. And as you say, an eastbound plane will try and get into those winds. And that's the reason why eastbound flights are usually about 1 hour faster than westbound flights. If you look at the airtime for the London to New York route, it's about 5 hours 40 on average for the eastbound and 6 hours 40 for the westbound. And that 1 hour difference is due to the jet stream winds. And as I say, they're getting faster. And that means that eastbound flights are going to get shorter on average, and westbound flights are going to unfortunately get longer as those westbound planes battle against the stronger jet stream winds.
And there's no way, is there, for a pilot to defeat this by going higher, for example?
I have looked at that, and it doesn't really help. The jet stream is getting stronger at all altitudes within the range that planes fly. And there's also no way around it by sort of trying to divert in the horizontal either. Not many people realize it, but when they board a plane, the airline has spent a lot of effort analyzing the atmospheric winds and calculating the best route. And they do that very carefully, because if they can just shave a couple of minutes off the flight time, that's going to save them well over 100 gallons of jet fuel, which is of great expense to the airlines. So they're already optimizing those flight routes, and they will continue to do so going forward. They've already minimized the journey time, and there's nothing extra left for them to squeeze out of the atmosphere. They've already pushed it as hard as they can.
So what you're saying is that, especially on a flight from London to New York or London to Boston, you've got to put more jet fuel in the plane. It's going to cost you more to fuel up.
On the westbound route, yes, they'll need that little bit extra fuel on the plane. And so, I mean, a lot of these changes are just the changes in the average flight time, but actually a lot of the interest is in the if you like, the very fast eastbound flights and the very slow westbound flights. And I've calculated that in the future, we're going to see a 130% increase in the likelihood of an eastbound flight coming in at under 5 hours and 20 minutes. The current record is 5 hours and 16 minutes, and that was made by a British Airways plane from New York to London about a year ago. So we're seeing I think we'll see much more record-breaking flights in future. But also, on the other hand, the probability of a westbound flight taking a very long time.
Is it not possibly just a question of swings and roundabouts, that you shorten one flight, even if the other flight is longer, the average, the net result is the same?
Yes, there is a degree of cancellation. So the eastbound flights are getting, on average, 5 minutes shorter, and the westbound flights 7 minutes longer. Those figures are for autumn. So they cancel out a little bit, but there's that 2 minutes left over. And there's a good mathematical reason why that's there. If you do a journey at 30 miles an hour, and then you do the return journey at 50 miles an hour, your average speed turns out actually not to be 40 miles an hour, which is what your first guess would be. There's something going on there in the mathematics that means they don't quite sort of add up in the way you think they will. That little residual, that's going to mean that airplanes are going to be in there for an extra 2,000 hours each year when you add it up for all of those transatlantic flights.
And is there a paradox at work here? Do we blame these jet trails for any degree of climate change? And is the fact that they're going to be pumping more aviation fuel into the atmosphere going to cause even more trouble up there?
Yeah, that's a good point. It's a bit of a vicious circle there, because we've known for a long time now that aviation makes a significant contribution to climate change. And what we're becoming increasingly aware of, and it's only really been in the past few years, is that climate change is going to have some knock-on consequences for aviation. One of those is more in-flight turbulence, for example, but also this study today on different flight times as well. But it is climate change that's causing the jet stream to change. Meteorologists have a good understanding of what drives the jet stream, and the temperature changes that we're inflicting on the atmosphere through our carbon dioxide emissions are changing the temperatures, and a knock-on consequence of that is that the jet stream is changing as a kind of response to the temperature changes.
Dr. Paul Williams.